So how do the tests compare? Well, the power of tests varies with significance level, sample size, and the distribution from which the data originates. As sample size increases, so does the power of the test to correctly reject the null hypothesis. Again, earlier we were talking about sample sizes. Sample sizes have a huge impact on the power of each individual test, and we're going to see that. It's actually really, really cool, but as engineers, we know more samples means more money. So by using this power comparison, we can really strike that balance between reliable and valid statistical analysis and reasonable costs and reasonable effort in collecting those samples. So based on academic literature, this is a general order. There's only one paper that actually compares all 6 of these directly, but a lot of them compare a couple here or there, and so this general order follows a lot of different research. And you'll notice here that the Shapiro-Wilk has Royston in parentheses, and that is actually because the Shapiro-Wilk, if you remember from our video, can only analyze up to 50 samples. So we use the Royston approximation to go all the way up to 5,000 samples. So the Shapiro-Wilk Royston is what was compared against these other ones in a lot of these studies because they go up beyond that 50 sample point. The Lilliefors, again, is that corrected KS. Ryan Joyner is an approximation of Shapiro-Wilk. And so you'll notice that the Shapiro-Wilk Royston and that approximation, the Ryan Joyner, are very, very powerful, both powerful. And here you kind of get to see that cool relationship between the Lilliefors test and the KS test, where the Lilliefors, the KS test is the least powerful by far in almost all of the literature. But just by using that test statistic and calculating the p-value a little bit differently, we see the power increase significantly, going from a test you probably don't ever want to use, which is the KS test, all the way up to being what is a great alternative and competes with the Shapiro-Wilk and is even better at certain sample sizes. And we'll see that in a second. But to me, that's just incredibly fascinating, that by taking a test statistic that's calculated the exact same and just a different p-value calculation, you can derive such an immense increase in power.